Hello everyone. Today let's solve the problem Watto and mechanism. Right. So this was asked in the Codeforces around 291 division 2. Right. So you can just go through the question. It is very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So I'll just summarize the question so that it will be easier for us to solve the problem. So what the question states here, we are given, oh, just give me a second here. Yeah, we are given n initial strings and m query strings. We are given n initial strings and m query strings. So these are the initial strings and these are the query strings. Just keep this in mind. Initial strings, query strings, right? So for each query, we have to check whether there exists a string in the memory of the same length that differs by exactly one character. So that we have to check for each query, this one, for each m, we have to check whether the string exists in the memory of same length, whether the string exists in the memory of same length, of same length, or differs by exactly one character, or differs by exactly one character, right? So this is the main condition. This is it for the question. This is the main condition for the question. So for each query, we have to check whether there exists a string in the memory of same length that differs by exactly one character, right? Each string contains only the characters A, B, C. Each string consists of the characters only A, B, and C. Right? So we have to return S for such query if match exists. Otherwise, no. If the match exists means if it is of the same length or if it differs by only one character, then in that case we have to return this one. Yes, sorry, not true. We have to return S. Else, if it does not match, then we have to return no, according to the question that they have given. So efficient handling is required here, as n and m has to be less than or equal to 3 into 10 to the power of 5. 3 into 10 to the power of 5. This is what they have given in the constraints, right? So I'll just read out the question loud one last time. Just listen to this. We are given n initial strings. See here, n initial strings and m query strings. For each query, we have to check whether there exists a string in the memory of same length that differ by exactly one character. Same length or it differs by exactly one character. Each string contains only characters A, B, and C. Each string consists of the characters A, B, and C. Right, so we have to return yes for such query if the match exists. Otherwise, we have to return no. We have to return yes for such query, and if it exists, then we have to return no if it doesn't exist. Means yes if it is of the same length or if it differs by one character. No if it doesn't exist, right? If it doesn't exist at all, then we have to return no, right? So this is mainly the question. Let's come to the input output part. So just give me a second here. I hope the question is completely clear, man. Easy to understand, right? So see here, we have 2n, n is 2 here and m queries is 3. See, just give me a second here. So yeah, initial strings, this is nothing but n, and m, this is query, right? So this is query. N is nothing but the initial strings and m is nothing but the query strings, right? So this is initial strings 2, 3 is nothing but the query strings here. So initial strings we have been given this one, double 5 times a, and this one, right? So and the queries is this one, queries is this one, right? So these three are the query strings or the this one m, and first two are the n, right? So don't get confused here. The output that we need to get here is yes, no, and no. The output for the input, this one, what do we call this one, we have to check with this one and this one. Again this one, second one we have to check with these two, right? So these are the initial strings, and third one also we have to check with these two, right? First one we have to check with this one, 5 times a, ac, this one ac a, right? This one double c ac a double c, this one also we have to check with triple times ac a and 5 times a, these two, and c double c triple ac, this one also we have to check with these two strings, first two strings, right? So this is what we need to do basically. It the only condition that they have given here is either it has to be of the first we have to check, see, suppose let's consider this one. First we have to check, suppose if we are checking with this one, uh, double a b double a. So I'll just consider this example. See here, we have to check with these two strings, first if it is of the same length. See, length is 1 2 3 4 5, double A B double A I'm considering. Length is 5 and length of the this one 5 times A is also 5. Here length is same. Then after length is same, we will check whether it differs by only one character. Yes, see here, only it differs by one character. B, we have only one character that differs here, that is nothing but B. So we don't have B in the 5 times A. We have A, and for second one we have A, right? So here in this case, this differs by only one character, that is B, right? This differs only by one character, that is B. In this case we have to return S. So in this case we have returned S. Same thing we will do with CCAA, this one double CAC A double C. We'll check with 5 times A and this one, the second this one as well, string as well, because we have been given 2 3 initial strings are 2 and the query strings are 3. We have to check these 3 strings with these two this one, what do we call, initial strings, right? So same thing we'll do with these two, double CAC A double C and C triple AC. This one also we'll check with this one, right? So this is what we will do, right? So let me delete this one entirely. Let's see the same thing in the approach menu. You'll understand this one clearly, right? So you have got the idea about the input output now, and also the question what we need to do, right? So now let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. First let's discuss the approach. See here, so I have considered the same first example that they have given in the question, so that it will be easier for us to understand the approach, right? So we have 2 3 here, n is 2, nothing but initial strings, and m is 3, nothing but the query strings, right? So these two we have to compare these two with this 3, right? So this is nothing but n here, this is nothing but m here, right? So the output that we need to get here is this one, yes double no. So first thing, we'll be going with a try data structure along with the DFS. Just keep this in mind. Let's understand the approach and then let's go with the try and DFS this thing. So this we will get to know when we write the code correctly. So this will not be a problem basically, to be frank, right? So here, so first let's discuss this one, how we got the this one s double no. First let's discuss the approach part, and then when we write the code you'll understand the try with DFS part. This is easy, man. I can bet on it. So I just want you to know that we'll be making use of the try along with the DFS for writing the code. We'll be going with the data structure try along with the DFS, depth first search, right? So let's move on with the step-by-step explanation here. The same example we have considered for the this one. Here initially we have 5 times A, 3 times AC and A, right? So the query strings are double A B double A, double C AC, A double C and C double A AC. First we have to compare this one with this one, right? Here see, we have A from this one, triple A, double A, or 5 times A. So there is only one mismatch here, B and A. Because here we have B instead of A. In the question they have given it should be of the same length and it should differ by only one character, right? So it differs by one character, and the length also, this is of the length 5 and this is of the length 5. You can check here. So this uh, satisfy the condition. This satisfies the condition, right? Or this satisfy the condition basically. Mismatch at index 2 basically. This is of index 2, 0 1 2, right? 0 it starts from. So B versus A we will be checking. Only one mismatch is found, so this is valid, and we are going with S here. We are going with S. So here in this case the first output that we got here is S, right? So this works correctly. Next let's move on with the second one here quickly. So we have the string, the query string, second one, this one, double C AC A double C, right? So we have to compare with this one with this one. What do we call? AC, 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 A, right? So here C and A mismatch here, right? Again, this is fine, this is fine. A is fine, A is fine. C is fine, C is fine. A is fine here. Again, A is fine. C is also fine, C is also fine. Now for the last character, we have C and we have A. So here two mismatches found, right? Here there should be only one mismatch. More than one mismatch is not tolerated, right? In that case we have to give no accordingly with the condition. So we will compare this one. So we have found more than one mismatch here, so this is not possible, this is not possible, right? So again, we will compare this one with the another query string. We have triple A double A, right? So here first one itself fails, CA, and second one also fails. So two mismatches found. Further, we don't have to carry on with the further operations again. So one thing is, before checking whether it differs by one character or not, length itself is different. So we have to first check whether the length is same or not, right? So this has 1 2 3 4 5 6 7. This is of the length 7 and this is of the length 5. Length itself differs, right? So different length. So this miserably fails basically. So the output that we need to return for the second one is no, right? So here have returned no. This is fine. Let's come to the final one. uh, Final one here, we have C double A AC. So length doesn't match. Again, we'll compare with first this one AC AC uh, AC A, or we can compare with 5 times A as well. It doesn't matter. So first let's compare with this one. So here see, length doesn't match here. So this is of the length 7 and this is of the length 5. Length doesn't matter, so this miserably fails here, right? So the next one is, we'll compare with 5s here. 5s, so the length is same, but see here we have 5, this one twice C. So mismatch is more than once here. Mismatch is more than once here. This also fails. These two things, this also miserably fails here, more than one mismatch. So this fails miserably. In that case also we have to return the output no. We have to return the output no here in that case as well. So we have written no here. We have written no here in this case, right? So this is how we got the output: yes, no, and no. So the output that we got here is this one. See here, yes, no, this one, second one no, and the third one no. So the output that we got here is yes, no, and no, which is equivalent to the output that they have mentioned for the this one, example one and the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So one more thing, we will be making use of the try, as I have said, to store all the initial strings. So we have to compare n with m, right? So we have to compare m with n or n with m, right? So we will be making use of the try to store the initial strings, means n. Basically this is initial string and this is the query string, right? So we will be making use of the try to store the initial string n part. Then for each query we will be making use of the this one. For each query we have three queries in the first example, right? So we have three queries. For each query we will be making use of the DFS traversal. We will be making use of the DFS traversal, and the try allows one mismatch only. Try allows here, this one, whatever try here is used to store the initial strings n part, right? So try allows only one match, only one mismatch, sorry, only one mismatch while matching the path. This is how we will be making use of the try along with DFS. Try along with the DFS traversal basically, or the DFS, right? So this part is completely clear. I hope this part is completely clear as well. So now we are completely familiar with the approach. As we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The overall time complexity would be big O of n into L plus m into 3 to the power of L, right? So big O of n into L in L plus, sorry, big of n into L plus m into 3 to the power of L. Why it is here, we can just consider n, right? N plus m we can consider. Why it is n into L plus m into uh, 3 to the power of L basically? We can just consider n into m here, right? In simple terms, why will we are going with n into L plus m into 3 to the power of L? N into L because we will be going with the insertion within the try, right? Insertion of the initial string. We are storing the initial string, nothing but n in the try, right? So n into L because we are going with the insertion of n strings of length, which is of length L, which is of the length L. This is the try part basically, right? So that is the reason it is n into L. And what is 3 to the power of L? Why it is not just m, it is m into 3 to the power of L? Because in the worst case, we are going with the DFS, right? In the worst case, DFS per query would be 3 to the power of L. But practically, it is fast since only there is one mismatch allowed and the characters are limited here in this case, right? So overall, this thing would lead to m into 3L. Overall, uh, time would lead to m into 3 to the power of L while we perform the DFS. So overall time complexity would be n into L plus m into 3L. It's not just n into m, it would be n into L plus m into 3 to the power of L. So what would be the space complexity here? Space complexity would be n into L. This we know. We are storing all the characters, all the strings character wise up to n into L nodes in the worst case in the try. So the overall space complexity would lead to n into L. This is easy man, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into L plus m into 3 to the power of L and big of n into L. I hope this part is completely clear, easy to understand, right? So now, as we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. Now, let's start writing the code, right? So I'll just come to the compiler here. So first, we'll be making use of the fast input and output. So we have to this one, import the input package, as well as we'll be making use of the utilities as well. So we have to import the utility package as well. So I'll just go with here, import java.io. This one. Sorry, what did I do here? Yeah, this is fine. Import java util.star. This is fine. So next part is, let me go with a class name here, public class. So this is main. Within the main class, so you can just name the class name anything. I'll just give main here. In this case, first thing, as we have discussed under this one uh, approach, we will be making use of the try, right? So we have to go with the node of the try structure first. So let me go with static here class. This is try node. This is try node. This is fine. So let me make this one capital T. This is fine. Try node. This is fine. So within this one, what we'll do, we have to go with the next of 0, next of 1, and next of 2, right? So we have to go with next of 0, next of 1, and next of 2 because we are considering the characters A, B, and C only. We are going with the characters A, B, and C only. So we can just go with the try node of 3 for this one, right? Next of 0, next of 1, and next of 2 for A, B, and C respectively. In the question, they have strictly mentioned, even in the approach, we considered first example, right? The characters consisted of only three. I mean, the string consisted of only three characters, A, B, and C, if you observe. Right, so now we have to consider next of 0, next of 1, or next of 2, only three characters here. So how can we articulate that one in the form of code? I can just write try node, try node here. I'll consider the variable next. This is new try node of this one 3. This is fine. I'll just delete this one entirely. The next step is we have to mark the end of the uh, we have to mark the end of the valid string, right? So here I'll just go with boolean is end. Boolean is end. Initially, let's assign this one to false, right? So let me do one thing. Sorry, yeah, this is fine. Let me come out of this one entirely. Next, let's write the this one code for the try part. Once we are going with a custom try part here, right? So I'll just go with static here class try. So if you remember, I said we'll be going with the insert operation, right? Insert operation. So within the class try, what shall we do? First, we have to consider the root of the try. If you remember, we have solved n number of problems in try in the LeetCode as well as this one. What do we call? Uh, Codeforces problems as well. While we solved in this one. Well, we use the programming language Node.js, right? So we have already solved. By this time, we have to have the knowledge of this one. What do we call? Try, right? First one, we have to consider the root of the try. So I'll just go with here try node, nothing but the syntax. Root equals here new, this will be try node. This is fine. This is nothing but the root of the try. Next step is we have to insert a string into the try. We have to insert the string into the try. For that one, we will be going with the insert method. That's what, right? So I'll just go with void. This one will be insert. This is fine. So why this is not taking? So this one will be insert. So let me go with string. Yes, let me go with the string s or the parameter s here. So first let me consider here node, and let me assign this one to root. This is fine. The next step is we have to go with the traversal or the iteration part. So I'll just go with a simple for loop here. Int I equals 0, int I equals 0. So this one will be I less than s dot length. And let me do one thing. Let's increment the I. So within the for loop, what shall I do? We have to convert this one character A, B, C to 0, 1, and 2. We have already discussed this one during this one. So this one is next of 0 is A, next of 1 is nothing but B, next of 2 is nothing but the C. Now we are within the for loop, we are converting character A or character B or character C to 0 or 1 or 2. So that's what we have to do. So for that one, same thing we have to articulate in the form of code. So I can just write here idx or the index, which is of type int. So let me assign this one to the s dot char at I, index I. So this one will be hyphen a hyphen a hyphen a. So let's write the simple if condition here. If node dot next of index, if this is equal to null, if this is equal to null, then what we have to do, we have to create the node if it is missing. So if the node is equal to null and if it is missing, then we have to create the node, right? So I can just write here node dot next of index. Let's create the node. So this has to be idx. Let's create the node. To create the node, we'll be going with new try node. We'll be going with new try node. This is mainly for the insert. So we are done with the last two steps, nothing but we have to move to the child. We have to move to the child, nothing but node. Let's assign this one to node dot next of idx, node dot next of idx. And the final part here would be we have to mark the end of inserted string. Every time in the try, we will be marking the end of the inserted string. Every time we make use of the try, just remember this one, we will mark the end of the inserted string. Any problem you consider in the try, we will be marking the end of the inserted string, right? So let's do that. Initially we have considered the boolean value false. Here in this case, I'll just consider node dot isEnd, and let me assign this one to the boolean value true. So this is fine. Let me come out of this one entirely. Let me come out of this one entirely. So now we have to search for the string that differs by exactly one character. We are done with the insert method, right? Now we have to search for the string that exactly differs by one character. Accordingly, with the approach we are going, same exact thing what we discussed in the approach, we'll be articulating in the form of code. So now we have to search for the string that differs by exactly one character. So I'll just consider the method boolean here. Search with one mismatch. Search with one mismatch. So this is fine. So this consists of the parameter SCR, which is of the type string. This is fine. So now within this one, to search for a string that differs by exactly character, we have to perform DFS. We have already discussed this one in the approach. We'll be going with the DFS for this one. So to make use of the DFS or to perform the DFS, let's make use of the helper function, DFS helper function. Let's make use of the DFS helper function. So I'll just go with here. We have to perform the DFS traversal, right? Let me do one thing. Yeah, let's go with here boolean DFS. So which consists of the parameter, this one node, this is fine, and also s, this is fine. String it has to consider. So this one also position. Position, I'll tell you. Position is nothing but the index in the string. So we have to go with the index in the string because we have to find out exactly which index differs. Basically, the character that is present at the particular index, uh, only one mismatch is allowed, right? Which one differs, we have to see. So that is the reason we'll be making use of the pvoice or the position, this one parameter here. And also let's go with the this one changed boolean changed. So this is fine. So within the this one, so here we will be going with the DFS traversal, nothing but position is nothing but the index of the string. Changed is nothing but whether one change is used or not to check this one boolean. So if more than one mismatch occurs, then we have to return no. Then we have to return no. If only the string this one the length of both the string are equal, means initial string and the query string is equal, then only we have to return s. Length as well as only one mismatch is allowed, only one mismatch in the character, only one character mismatch is allowed, only then we have to return s, else we have to return false. That is the reason we are making use of here this one position and the changed. So position is of the type int, man. So I forgot here to write the int. Yeah, int position. So this one boolean change, this is fine. Oh, let me use space here, this is fine. Yeah. Why this try node? Did I give anything wrong here? This is fine, right? Yeah, this is fine. So within this method, first step is we have reached null node if it is a invalid path. So how can I write that one? If node doesn't exist or if node equals null, then we have to return false in that case. Then we have to return false in that case. So next step is we have reached end, or we will return true if exactly one change is used, if exactly one change is used. So let me go with the if condition here. If position equals start length, we can just write it in this way. This is easy. I can just go with return changed, and also we have to go with node dot isEnd is end. This is fine. So we have reached end here. We have successfully reached the end, and we have to return true, right? So we have to return true if exactly one change is being used here, right? So this is fine. We are done with this. But next, we have to go with the index of the current character. We have to go with the index of the current character. So I'll just go with int idx. Let me assign this one to s dot this one caret. So we are going with the index of the current character, right? So I'll just go with a hyphen a. I'll just go with a hyphen a. This is fine. So the next step is here for loop. Simple for loop means we will be trying, or we have to try all the possible characters, nothing but a, b, and c. A, b, and c are the only characters, or only the three characters that will be present in the input they have given in the question. They have strictly mentioned in the question. Now we have to try all the possible characters a, b, and c. Let's go with the iteration, right? So let's move on with the iteration part. This will be int I equals 0, I less than 3. This will be I plus plus. Within the for loop, we have to skip if no child exists. Means here I can write in this way: if node dot next of I this one, if it is equal to null, then I'll just give the, we have to skip, right? So for skipping, I'll just make use of the continue keyword that is given by the Java, right? So this is fine. So next, if I is equal to the index, then we have to match without change. Also, we have to try one change. If I equals index, or else if it is not of changed, right? So these two conditions we have to go with. So first, let me write this one, you'll understand. First, let me write the simple if condition here. So how can I write this? Just give me a second here. We are skipping if no child within the first if condition. This is fine, man. So here, if I equals index, we are comparing here. If I equals index means both are same, both are same. The character that we are considering within the this one query string, and the character within the this one initial string, if it is same, then we have to match without the change. Then we have to match them without the change. Here we will be going with the recursion, we'll be going with the DFS part. So this one I can write in this way: if DFS of node dot next, yeah, node dot next, iterative value of node dot next, comma s, right, comma s, comma position plus 1, comma position plus 1, comma changed here, comma changed here. This is fine. In that case we have to return, in that case we have to return true, in that case we have to return true. This is fine. So this was easy, previous one was easy. Else if not of changed, else if not of change. So we have to go with one change only, or we have to try one change, right? So that itself we have to articulate in the form of code. Means if there is only one change between the initial string as well as the query string, then in that case also there exists only one mismatch, and we have to return true in that case as well, right? So if the length is same and if there is only one mismatch, then only we have to return true, else we have to return no, then only we have to return s, else we have to return no, right? So here in this case we are going with the boolean value for now. We are not giving yes or no, we are just going with the boolean value, then we can just go with yes or no in the main function, right? So now if there exists only one mismatch, then we have to return true in this case. So again, let's go with a recursive DFS here. If DFS of node dot next here of I, this one, comma s, comma this one position plus one, if there is only one mismatch, right? So then we have to return true, right? So true here, let me come outside and let me return true here as well. I hope this part is completely clear. And finally what we will do here, we have to return false, or we if we have not found any valid path, or if there is no valid path that is found, then we have to return false in that case. So let me give here return false. I hope this part is clear, man. I hope this part is completely clear. Now as we are done with the DFS, this one, what do we call, helper method, we can make use of it within the search with one mismatch method. We can just make use of this one, DFS within the search with one mismatch method. So I'll just give here return DFS of what are the parameters we need to pass, root s comma 0 comma false. So this is fine. So we are starting the DFS from root with no change at here. In this case we are starting the DFS from root with no change yet here. So this is fine. We are done with this part. We are done with the try part where we went with the insert, and we are done with the search with one mismatch method along with the DFS. We are performing the DFS here and making use of that DFS part within the search with one mismatch method, right? So we are done with these things. Now what we need to do, let's go with the main method. So we are left with this thing. Here we are checking with the boolean value true or false. So if everything goes well, then we have to return the yes within the string. So the output has to be yes or no, not the true or false. See here, right? Yes or no, that we mainly write it in the main function. So just give me a second here. Did I miss out anything? No, right? So this is fine. Let me come out of this one entirely. So let me go with the main method or the main function. So here, so this is fine. So let me remove this one. It's fine. Also let me make use of the throws input output exception. So within this method, so within the main method, what we'll do, we'll be making use of the fast input and output, nothing but the buffered reader and print writer. So I'll just go with buffered reader br equals new buffered reader. So this one will be new input stream reader of this one, system.in. This is fine. Also let me go with the print writer here. So not this one, print writer. So I'll just consider this will be the output, right? So either you can consider pw or output out as well. So I'll just go with the out here. This is fine. Print writer variable out I'll consider here. This one will be new print writer, new buffered writer, new output stream writer of system.out. So this is fine. Let me give the semicolon here. So output stream, right? So this is it for the input output part. So we will be making use of the string tokenizer as well. So I'll just go with string tokenizer here. This one will be st variable. So I'll just assign this one to string tokenizer pr dot. So this one will be read line. This one will be read line. So this is fine. Dot read line. So this is string tokenizer. So I have given this one correctly, right? String tokenizer. This is fine. So next we have to go with the number of strings in memory. Also we have to go with the number of queries. First let's go with the number of strings in the memory. So I'll just go with n and let me assign this one to integer dot so %. So we have only integer, so we'll be going with the integer dot % here. String tokenizer dot next token as usual. So we have done this one in n number of problems, right? So understanding this one will not be a huge deal, big deal, right? So now we have to go with the number of queries as well. This will be int n m. This is nothing but the query strings, right? So this one will be same thing. Let me copy the same thing here until here and let me paste it over here. So this is fine. Right, so we have went with the number of strings in the memory, nothing but this is nothing but the initial strings, nothing but we are making use of try for this. And for this one, we are going with the this one. What do we call m is nothing but query strings, right? So this is fine. This is used for the comparison with the initial string, right? So this is fine. The next step is we have to create a try instance. We have to create the try instance again. I'll just go with try equals, let me go with new uh try new try. This is fine. So we have successfully created a try instance. Now after doing this one, we have to insert all the memory strings. For that one we have to insert all the memory strings, right? So for that one, let's make use of the iteration but nothing but the for loop here. So int I equals 0, I less than m. We are going with the memory strings, right? So we will be going with the n. We'll be going with the n, nothing but the initial strings. So this will be I plus plus. So this will be try dot insert of this one will be buffered reader dot read line. Buffered reader dot read line. So this is fine. Let me come out of this for loop entirely. So let's process the each query now. Let's process the each query. So this, if there is only one mismatch and if the length are equal, if the length of query parameter and the this one, what do we call initial string, are equal, and if there is only one mismatch, then only we have to return s. That let's do that itself. Else if there is if the length are not equal, or if this one, what do we call, if there is more than one mismatch, either of them, right, either of them exists, then we have to output no. Then we have to output no in that case, right? So let's articulate the same thing in the form of code. Now let's process each query. Let's go with the for loop here. For int I equals 0, I less than m. So this will be I plus plus. So here, yeah, this is fine. Within the for loop, what shall we do? I'll just go with the variable query. So this one, let me give small q here. This is fine. This will be buffered reader dot read line. Read line. So this is fine. Let's go with a simple if condition here. This is try dot search with one mismatch method. We have already written this one. Let's pass the query. Let's pass the query. If everything works right, then we have to print s. Then we have to print s, right? So I'll just go with println. This one is s. This is fine, easy, right? So else what we need to do here? We have to print no. We have to print no. So this will be out dot println. So then if either of the condition means we have already discussed this one, right? So here this one will be no. Means if the length differs, or if there is more than one mismatch, then we have to print no. So that's what we are doing here. This is fine. We are done with uh, almost we are done with everything except that one thing. We have to flush the output buffer. Either we can go with out dot close or out dot flush here. So I'll just go with out dot flush in this case. Out dot flush in this case. So we are done with the coding part here. We are done with the coding part, right? So let me come here. So let me do one thing. Before checking the code whether this works or not with the different inputs, let me do one thing. Let me copy paste the signature starter template. So let me come here. So where is this one? Sorry. Yeah. So let me paste it over here. You can just ignore this part. You can just concentrate on the logical part. So let me come to the question here. Let me copy the different inputs here. So the output that we need to get here is S double no. Let's see. Let me give the input here. Let me hit the run button. So we have, oh, this one has to be capital P, man. Where is this? Line number 68. Is line number 68, 68. Yeah, this one has to be print writer. So this has to be capital P again somewhere. So let me run this one now. Yeah, now we are getting the output S double no, right? So this has to be capital P, right? We are using the print writer for the this one fast output, right? So here this has to be capital P at any cost. So this is fine. We are getting the output S double no for this particular input. So this works absolutely correct, right? We have to get the output S double no. So let me copy this entire thing. Let me come here. So we have to select C. I had already selected. Yeah, let me select this one again. This is fine. Now I have pasted the code. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. So let's wait for some time. Let's wait for some time, man. So you can clearly see here our code works absolutely correct because this got the code got accepted, right? So you can clearly see here to almost right. So we have the time this thing limited to 3 seconds basically. Time restriction is 3 seconds. So this is 2952. So yeah, this is fine. Code got accepted. So whatever the code that we have written works absolutely correct for all the test cases, right? So whatever the code that we have written works absolutely correct for all the test cases. We went with the try with DFS. We went with try with DFS traversal. That's it, right? So I hope the solution part is completely clear, man. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.